Welcome back, future solutions architects. In part 4 of our SAA-C03 series, we're diving into 5 high-yield questions that often decide who passes and who struggles. Stick around for expert explanations and real-world insights you won't find in textbooks. Question 21. What is the most secure way to allow public user for a limited time from accessing a file stored on Amazon S3 and is 10 gigabytes in size? This question is testing whether you know the secure and temporary way of sharing S3 objects. The key points here are: it must be secure. It should be for a limited time. The file is stored in Amazon S3, so think carefully. Which option lets you share a file without permanently making it public and allows you to control time-based access? The options are: A. Generate a pre-signed URL and have the vendor download the log file before it expires. B. Enable public read on the S3 object and provide the link to the vendor. C. Upload the file to Amazon Workdocs and share the public link with the vendor. D. Create an IAM user for the vendor to provide access to the S3 bucket and the application. Enforce multi-factor authentication. Let's quickly break this down with real-world thinking. Option B. Public read would make the file public to everyone, which is not secure. Option C, Workdocs, is a different service altogether and not the best solution for large S3 files. Option D, IAM user, is overkill. Imagine creating an entire user identity just for someone to download one file, and it could be a security risk. Option A, Presigned URL, is perfect because it lets you share the file temporarily. For example, you can give a vendor a URL valid for only 24 hours, after which it stops working. The correct answer is: generate a pre-signed URL and have the vendor download the log file before it expires. The pre-signed URLs are valid only for the specified duration. All objects by default are private. Only the object owner has permission to access these objects. However, the object owner can optionally share objects with others by creating a pre-signed URL using their own security credentials to grant time-limited permission to download the objects. When you create a pre-signed URL for your object, you must provide your security credentials, specify a bucket name, an object key, specify the HTTP method, get to download the object, and expiration date and time. The pre-signed URLs are valid only for the specified duration. Anyone who receives the pre-signed URL can then access the object. For example, if you have a video in your bucket and both the bucket and the object are private, you can share the video with others by generating a pre-signed URL. Question 22. As solution architect, you have a requirement to design online stock trading system, which will heavily use transactional and scalable database with high write consistency. Each order will be saved in multiple linked tables. This question is focusing on choosing the right database for an online stock trading system. Key requirements are: the system is transactional, meaning it must handle multiple operations reliably. It must be scalable, able to grow as demand increases. Needs high write consistency. Data accuracy and reliability are critical. Uses linked tables, so we're dealing with a relational database. With those keywords in mind, think about which AWS database service best matches this description. The options are: A. Amazon DynamoDB, B. Amazon S3, C. Amazon Redshift, D. Amazon Aurora. Let's analyze each option. DynamoDB. Great for scalability, but it's a NoSQL database, not meant for relational tables or complex transactions. S3. This is object storage, not a database, so it doesn't fit the requirement. Redshift. Excellent for analytics and data warehousing, but not ideal for real-time transactional systems. Aurora. Perfect fit, because it's a relational database that supports transactions, scaling, and consistency. Think of a stock trading system. When a user buys a stock, multiple tables, like orders, accounts, balances, must update instantly and consistently. Aurora is designed for exactly this type of use case. The correct answer is Amazon Aurora. Tip: transactional plus scalable database, plus high write consistency, plus linked tables equals Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases with the simplicity and cost-effectiveness of open-source databases. Amazon Aurora is up to 5 times faster than standard MySQL databases and 3 times faster than standard PostgreSQL databases. It provides the security, availability, and reliability of commercial databases at 1/10 the cost. Amazon Aurora is fully managed by Amazon Relational Database Service, RDS, which automates time-consuming administration tasks like hardware provisioning, database setup, patching, and backups. If this video is helping you, support us by hitting the like button, and don't forget to subscribe for more content like this. Question 23. A multinational scientific company has a scientific web application which is hosted on a single Amazon EC2 instance and use Amazon EBS volume to store used uploaded documents. The company decided to create same architecture on a second EC2 instance and EBS volume in another availability zone. Both EC2 instances are behind application load balancer to provide highly available and scalable application. Recently, the operation team received a lot of complaints from users that each time they refreshed the website, they could see one subset of their documents or the other, but never all of the documents at the same time. What should a solutions architect propose to ensure users see all of their documents at once? This question is testing if you understand the difference between EBS and EFS. Key details. Users upload documents to EBS, which is tied to one EC2 instance. A second EC2 instance in another availability zone also uses its own EBS. Load balancer switches users between the two instances. The problem, users don't see all documents because data is stored separately on two EBS volumes. The question is asking, how do we make sure both instances share the same storage so users always see all documents? The options are A. Configure the application load balancer to direct a user to the server with the documents. B. Copy the data so both EBS volumes contain all the documents. C. Copy the data from both EBS volumes to Amazon EFS. Modify the application to save new documents to Amazon EFS. D. Configure the application load balancer to send the request to both servers. Return each document from the correct server. Option A. That would force users to one server, but defeats the purpose of load balancing and high availability. Option B. Copying data manually to both EBS volumes is not scalable and still doesn't keep them in sync. Option D. Load balancer doesn't work this way. It can't send one request to multiple servers and merge responses. Option C. This is correct. Amazon EFS is shared storage that multiple EC2 instances can access at the same time. This way, no matter which instance the load balancer routes the user to, they'll always see all documents. Think of EBS like a hard drive attached to a single computer, while EFS is like a network drive that many computers can use together. The correct answer is copy the data from both EBS volumes to Amazon EFS. Modify the application to save new documents to Amazon EFS. Shared storage between multiple EC2 instances. Use Amazon EFS. Amazon EFS is designed to provide massively parallel shared access to thousands of Amazon EC2 instances, enabling your applications to achieve high levels of aggregate throughput and IOPS with consistent low latencies. Amazon EFS is well suited to support a broad spectrum of use cases, from home directories to business-critical applications. Customers can use EFS to lift and shift existing enterprise applications to the AWS cloud. Other use cases include big data analytics, web serving and content management, application development and testing, media and entertainment workflows, database backups, and container storage. To get the free PDF or mock test, comment PDF or mock or both. I will share the downloadable link within the next 24 hours. Question 24. A solutions architect is designing a static pages. The pages are expected to generate millions of views from users around the world. These pages are stored in an Amazon S3 bucket. What is the efficient solution to handle this requirement? This question is about how to efficiently deliver static content like HTML, CSS, images, videos, or documents stored in Amazon S3 to users all over the world. Key points. The pages are static, no need for a database. Expected millions of views, so scalability and cost efficiency matter. Users are global, so low latency worldwide delivery is important. So the question is asking, what AWS service can make static files stored in S3 load faster and scale better worldwide? The options are A. Use Amazon EFS to store and server static files. B. Enable Amazon Elasticache in the web server subnet. C. Generate Presigned URLs for the files. D. Use Amazon CloudFront with the S3 bucket as its origin. Option A. EFS is shared file storage for EC2 instances, not the right fit for global static content delivery. Option B. Elasticache speeds up database queries, not static web pages. Option C. Presigned URLs are for secure temporary access, not for handling millions of global requests. Option D. CloudFront is a content delivery network, CDN, that caches files at edge locations worldwide, reducing latency for global users. This is the most efficient and scalable solution. Think of CloudFront as setting up local delivery stations for your S3 files around the world, so users don't have to fetch data from one central location every time. The correct answer is use Amazon CloudFront with the S3 bucket as its origin. Static content on S3 equals use CloudFront. When you use Amazon S3 as an origin for your distribution, you place any objects that you want CloudFront to deliver in an Amazon S3 bucket. You can use any method that is supported by Amazon S3 to get your objects into Amazon S3. For example, the Amazon S3 console or API, or a third-party tool. You can create a hierarchy in your bucket to store the objects just as you would with any other Amazon S3 bucket. Using an existing Amazon S3 bucket as your CloudFront origin server doesn't change the bucket in any way. You can still use it as you normally would to store and access Amazon S3 objects at the standard Amazon S3 price. You incur regular Amazon S3 charges for storing the objects in the bucket. For more information about the charges to use CloudFront, question 25. A multinational bank uses an Amazon RDS PostgreSQL DB instance to store its application data. At end of each month EOM, the financial team needs to generate some reports. What should a solutions architect do to reduce the impact on the database with the least amount of effort? This question is about how to offload reporting queries so they don't affect the main production database. Key points. Database is Amazon RDS PostgreSQL. Reporting is done monthly, so heavy queries might slow down production. We need to reduce impact on the main database. We want the solution with the least amount of effort. So the question is asking, how can we let reporting run without slowing down the main application database? The options are A, create a cross-region read replica and direct reporting traffic to the replica. B, create a multi-AZ database and direct reporting traffic to the standby. C, create an Amazon Redshift database and direct reporting traffic to the Amazon Redshift database. D, create a read replica and direct reporting traffic to the replica. Option A, cross-region replicas are more useful for disaster recovery or global distribution, not necessary here. Option B, multi-AZ is for high availability failover. The standby cannot be used for reporting. Option C, Redshift is for data warehousing and analytics. Setting it up would take more effort, not the least effort. Option D, this is correct. A read replica can handle reporting queries while the main database focuses on production traffic. Think of it like having a photocopy of a book. People can read the copy, read replica, without disturbing the original book, main database. The correct answer is create a read replica and direct reporting traffic to the replica. Tip: to generate reports without affecting the database performance, use read replicas. Amazon RDS read replicas provide enhanced performance and durability for RDS database DB instances. They make it easy to elastically scale out beyond the capacity constraints of a single DB instance for read-heavy database workloads. You can create one or more replicas of a given source DB instance and serve high-volume application read traffic from multiple copies of your data, thereby increasing aggregate read throughput. Read replicas can also be promoted when needed to become standalone DB instances. Read replicas are available in Amazon RDS for MySQL, MariaDB, PostgreSQL, Oracle, and SQL Server, as well as Amazon Aurora.